Welcome to Chapter 4.7, Quadratic Formula. Yay!
So, if we remember from previous experience, we have the quadratic formula is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to skip this first step. We will do this in class. So if we look at the bottom here, we're going to use the quadratic formula to solve, and then we want to give exact solutions. If we take the first one, we need to move everything to one side. So if we move the 4x over, we're going to get 3x squared minus 4x minus 6 equal to 0. So we set everything equal to 0. We need a. A is equal to 3, b is equal to negative 4, and c is equal to negative 6. So if we plug in, we get x equals the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 6 all over 2 times 3. Simplifying, we're going to get x equals 4 plus or minus. We're going to get the square is 16. Two negatives make a positive, so we have 12 times 6, which is 72. So plus 72 all over 6. So x equals 4 plus or minus the square root of 88. So we're going to have to simplify that 88, hopefully. We get x equals 4 plus or minus by simplifying the radical. You should get, which is really 4 times 22. We're going to get 2 radical 22 all over 6. If you notice on the top, we can take out there's a 4 and a 2, so we can take out a 2 from both of these. So we're going to get x equals 2 times 2 plus or minus radical 22 all over 6. And then the 2 we just took out goes into 6. So we get equal to x equals 2 plus or minus radical 22 all over 3. And this is the exact answer. If we look at the problem on the right, your school's jazz band is selling CDs as a fundraiser. The total profit Y depends on the amount X that your band charges for a CD. This equation is Y equals negative X squared plus 48X minus 300. As you look at that, you should notice that it is a parabola with the x squared. It is a quadratic, but it also opens down. Okay, so that models the profit of the fundraiser. We need to know what the least amount of dollars you can charge for a CD to make a profit of $200. So if you realize we need a profit of $200, that's what's going to go here. We need to substitute in $200 for y, and then we need to solve for x. Now you notice we'll get two answers, and we need to figure out which one is the least one. So if we plug in, we're going to get 200 equals negative x squared plus 48x minus 300. When we deal with quadratic formula, we need to move everything to one side. Let's move everything to the left because of the negative x squared. So by moving all three terms on the right over to the left, you're going to get x squared minus 48x plus 500 equals 0. So we know that a equals 1, b equals negative 48, and c equals 500. Using the quadratic formula, we're going to get x equals the opposite of 48. So 48 plus or minus the square root of 48 squared minus 4 times 1 times 500 all over 2, or 2 times 1. X equals 48 plus or minus, well, 48 squared minus the 4 times 1 times 500 should give you the square root of 304 all over 2. Now, because we are actually dealing with money, we need to figure out, we can't just leave the radicals, so we can change everything to a decimal. And if we take the first answer, we go 48 plus whatever the square root of 304 is, divided by 2. And we do the second one, which is 48 minus the square root of 304 divided by 2. We get two answers. One answer is going to give you 32.72, and the other answer is going to give us 15.28. Now these are in dollars, so if we notice, we want the least amount. So our x equals $15.28 is going to be our least amount. We need to find the zero x-intercepts roots by setting y equal to 0 and using the quadratic formula. Hit pause. I'll see you back here in a few minutes. Welcome back. If you check your answers over on the number 1 with the blue, you should have had x equals -5 and x equals -7, or the two x-intercepts are -5, 0 and -7, 0. Number 2 in the green, you should have had just one x-intercept, which if you're picturing the parabola, the vertex is on the x-axis. It has a double root, is what we call. X-intercept is 3, 0. And on the red for number 3, you should have had no real solutions, meaning we cannot take the square root of a -20, so you're not going to get any real solutions. You will have an imaginary solution. Okay. Putting all this together, if you take our answers right there, slide this down, we need to figure out, well, how many real roots does it have? What are the number of x-intercepts it has? And then we need to figure out, well, what do we call the discriminant? On number 1, based on the two answers we got x equals -5 and x equals 7. That gives us 2 x-intercepts. Well, those are actual real answers, so we can call those 2 real roots. If we go to the middle one, we only have one solution, therefore there's only one x-intercept, and it actually is a 3, which is a real number, so therefore we have one real solution. And then the third one, we don't have any solutions or no real intercepts, so we have 0 x-intercepts and 0 real roots. Okay. If we concentrate, and you notice, what is underneath the radical sign? So we have this 4, in the middle one we had 0, and in the last one we had -20. That's going to help us determine certain answers. Okay, the b squared minus 4ac that gave us that answer before we square root, that's called the discriminant. So in the first one, the discriminant was 4. The second one, the discriminant was 0. And the third one, the discriminant was -20. Okay. By getting those answers, so the 4, the 0, and the -20, that's going to help us with our solutions, or to understand our solutions. So summarizing everything, in the quadratic equation ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. That's without taking the square root. So do not take the square root of that. Okay, we can get really 3 solutions. So if you remember back to that first problem, we got 4. Well, if we compare that to 0, okay, we can get an answer that's greater than 0. The middle one we got equal to 0, and then the last one we got less than 0. So first one was 4, the middle one was 0, and the last one was -20. So if you notice, if we flip back and we say, okay, we had 4. Well, how many actual solutions did we get? We had 2. If the discriminant was greater than 0, we had 2 solutions, and therefore there were 2 x-intercepts. If we go to number 2, we actually got 0, which gave us just the 3, which was one solution. So it has one real solution, and we actually call that a double root, because we got 2 answers, but they both were the same, and therefore it's only one x-intercept, where the vertex was on the x-axis. And the last one, we got -20, which is less than 0. It has no real solutions. There are no x-intercepts. So in number 1, 2, and 3, we're going to find the discriminant and determine the number of real solutions without actually solving the equation. Okay. One note to go back, though, too, is if you get the discriminant to be a perfect squared, 1, 4, 9, 16, 25, and so forth, then you can actually factor the equation instead of maybe quadratic formula. So if we look at number 1, Okay, we have b squared minus 4ac. Negative 6 squared minus 4 times 3 times 4 is going to give us 36 minus 48, which is negative 12. That is less than 0. So negative 12 is less than 0, so we get no real solution. Go ahead, hit pause. Do number 2 and 3. I'll see you back here in a few minutes. Hey, welcome back. If you notice, remember the discriminant is b squared minus 4ac. Whenever we're working with quadratics and we want to do the discriminant, again, move everything to one side, set it equal to 0. So by plugging into the appropriate places, you should have gotten negative 12. Negative 12 is less than 0, so you should have no real solutions, no x-intercepts. Number 2 was equal to 0, so therefore if we had 0, we can see just straight above that you get one real solution, a double root. And if we look at number 3, you should have gotten 12. We can take the square root of 12, so we're going to get some 2 real solutions. They may be rational, they may be irrational.
Do the best, forget your rest. Bye for now. Ow!